Hello, Midnight Coders, and welcome to a video about exception handling within Spring Boot. So today we're going to take a look at a small product API, and I'm going to walk you through how it currently handles errors and why that leads to those lovely but useless 500 internal server errors. And what it is that we as developers should really be aiming for instead. We'll run over why this looks like it works, but reveal the pitfalls of the bad error messages. Then we will wire in a REST controller advice, turn those vague 500s into something more meaningful with consistent API errors. So, make sure you've got that full cup of coffee, and let's dive on in. All right, picture this. You're consuming a nice Spring Boot API. You call the endpoint, fetch a product ID, and then all of a sudden, it explodes. 500 internal error. No idea what went wrong. No idea if the product doesn't exist. No idea if you called the wrong endpoint. No idea if the whole backend is on fire. No idea. From the backend side, the code looks fine. We have a neat little service layer. We throw custom exceptions when something goes wrong. But because we don't handle those endpoints centrally, client gets a generic 500. So in this video, we are going to walk you through the current code, show you those exceptions and how they bubble up, and then explain why just let it throw a 500. It's not exactly good enough once you move past the beginner level. We'll use the @REST controller advice to turn those raw exceptions into clear, predictable HTTP responses. Let's have a quick overview of the project. So on screen, I've got a very simple Spring Boot application with a classic layered structure. We have a controller package for the REST endpoints. We've got a service package for the business logic, a repo package for the repositories using Spring Data JPA. We have a model package for the product entity, and an exception package with the custom exceptions for product not found, product duplication, or there was a update issue. This is exactly the kind of structure that you'll see in most real Spring Boot applications. The main player of this video is the service layer. This is where we decide when to throw errors and the exception cases that we want to throw. So to zoom out or zoom into the project service a little bit, we've created an interface which defines the contract. So this would be our CRUD operations. Let me make this a little bit bigger so you can see it. So this references our contract to do CRUD operations. So to create, to read, to update, and delete, as well as we're contracted to save. So then we go into our implementation where we take care of some logic. Everything's good so far, right? The controller calls into the service talks to the repository. Everything should be fine. So now the important bit. What happens when something goes wrong? So say we try to get a product with a specific ID, but what if the product with a given ID doesn't exist? So then we throw a new product not found exception. And if we peek into these exceptions, these are just very simple exceptions which extend a runtime exception and take in a string to throw. That is the same for the product update issues, product duplications, and from the backend perspective, this is all right. We're not returning any nulls. We're not juggling error message codes. We're using meaningful domain-specific exceptions. And this is exactly a pattern that I would expect a mid-level dev to use inside the codebase. So now, these exceptions, as I've said, they just extend the runtime. They take in a string so that we can throw the message. They don't contain any HTTP information. They don't know anything about status codes. They're purely about domain. This product cannot be updated. This product cannot be found, so forth. And that's actually a good thing. Your service layer and your domain code should not be littered with HTTP concerns. So far, this design is fine. And the problem appears at the boundaries. So when this exception leaves the backend and becomes an HTTP response. So let's trigger one of these exceptions from the outside and see what happens. So if we run the product program, here we go. It has started. We can see this in the console that it's finally started, up and going. Now, what if we pop into one of our endpoints and we want to post a new product? We'll say, call this one mentorship, and we'll just say Java mentoring for junior devs. Something simple, right? So we can submit this request. Looks like it went through. Everything's fine. 200, okay. This is very meaningful. But now, if we submit this again, we're just going to get an ugly 500 that something went wrong. Okay. Well, let's try to see if we can at least get our product. So let's say product ID 1. And if we submit this, everything is good. We got our response back. We can see here, everything was fine. It was 200. Everything is good. And we got exactly what we wanted. Now let's say that we want a product 0. Oh, backend must be on fire. Okay, so this tells us again, something went wrong, but again, it's not what we want. So we send these requests, we fetch a product that doesn't exist, or maybe we try to update or anything else. The service throws custom exceptions, but they're not explicit in handling in the controller. If we look at the console, we can see our custom exception that was thrown, product with ID 0 not found. Little more helpful, but it's only in the console. So now, depending on your setup, the user might either get this 500 error, they may get a generic JSON or even an HTML page with just a generic 500 message. Maybe the exception name might be in the message if you haven't really locked down on that. But from the API consumer's perspective, this is incredibly unhelpful. Because what if your API, what if you're accessing the public API that return just 500s? You have no idea if the product is missing, if there was invalid input, if the server was down. All you see is just 500. And from an operations perspective, your monitoring is now screaming server error for what might only be a missing product or a bad ID. So why is this not good enough? Well, let's talk about that. Let's talk about why this is not a good enough approach. Okay, let's step back and think like a senior engineer for a moment. Why is this approach problematic? So, a missing product isn't necessarily a broken server. It's usually a client level issue or a normal business outcome. Because let's face it, you might just not have the product. So product not found should be returning a 404, whereas a duplicate product should maybe return a 409 conflict. Invalid data could be 400 bad request or maybe 422 unprocessable entity. So even if the error becomes a 500, we lose the meaning in the HTTP status codes. Maybe it's a bad experience for your consumers, because when teams are integrating with your API, they need to be able to say if a 404 that this was not found. They want to programmatically react to different failure methods. If everything is just 500, something went wrong, they can't distinguish between try a different ID, wait and try again later, file a bug report because something broke. This also can lead to polluted monitoring and logs. So in production, we usually treat 500s as the server did something wrong, and this is the kind of thing that wakes up a developer at 3 a.m. If every day expected conditions like a missing product, are your 500s really that good? They can lead to a cluttered dashboard. Alerts become a lot less meaningful, and it becomes harder to spot a real system failure. There are inconsistencies across the code base. So without a central strategy, each controller or service might throw different exceptions, expose different messages, and end up returning slightly different responses than you expected. It works, but it's fragile. One new endpoint written by a different developer can suddenly behave completely different on your errors than what you expected. So what we're currently missing is a translation layer. So the core idea here is this. Inside of the code, we're already doing something good. We have domain-specific exceptions, clear messages, and logical places where errors are thrown. But we stop halfway. We never actually translate those domain exceptions into HTTP responses. The translator layer is exactly where controller advice and REST controller advice come in. Think of them as a global HTTP API friendly exception mapper. Your controllers and services throw normal exceptions, and then a REST controller advice class sits in one place, listening for those exceptions. When it sees, for example, a product not found exception, it'll return a 404 instead of a 500, and it'll wrap it in a consistent JSON-like structure. For example, error code is product not found, message, product with ID 123 not found, timestamp, yada yada, path, yada yada. You define it once, and it applies across all controllers, all service layers. So if you throw an exception in your service layer, if you throw an exception in your controller or your REST controller, these will pick up and translate to meaningful messages for your consumers. So how do we design a consistent error payload? Let's take a look. First, we will need to create our new API error, which is going to be a record. And I've just to do save some typing. There we go. So here we had an API error message. So this is going to consist of a timestamp, a status code, an error, a message, and a path. Nothing more, nothing less. Very simple, with a very simple way of creating one. Next, we're going to need to build a global exception handler. So here I've created a product exception handler that is annotated with the REST controller advice. This is because our controller is of type REST controller. So we made a REST controller advice. Now in here, we have an API error of type not found, which we annotate with the response code of not found. We tell it that the exception that we're handling is product not found exception. So here we take in the product not found and we take in the servlet request. So this way we can reply to it. And then we return an error of not found. We say the product was not found, and then we provide the message and the request path. We do the same for duplication so that we can return conflict. We do the same thing for product update. We are handling an already reported. And then for all other exceptions, we are returning a 500 with a more meaningful structure. So the REST controller advice tells Spring this class contains global exception handling for specific types of exceptions. Because this is a REST controller advice, Spring will automatically serialize and return API error as a JSON object. So now the client gets consistency and sees something more meaningful rather than just 500, the host is on fire. This keeps our error messages more consistent, as well as it also will clean up potential monitoring and log issues. So now, if we rerun the project, go back to our endpoints, and if we post the product, we see that it's up here like we got before, 200, everything's okay. If we send it again, now we get a 409 telling us that the product already exists. That is something more meaningful that we could react to. Now, if I was to go and try to get a product, if we try to get product 1, we got our meaningful 200 with our exact object. Now, if we try to get product 0, 404, product not found. Again, now our program is returning proper output. So things become a little bit more predictive. Anyone that consumes our API can now react to the proper errors. All right, so the lesson here isn't that we just added a REST controller advice. It is that we use domain-specific exceptions in our services. We've centralized your exception to HTTP mapping to just one place. We've defined a consistent error payload like API error. And now we reserve the 500 errors for legitimate server problems. And of course, we've also made our API errors something that our consumers can actually rely on, not just react to. So once you start thinking this way, exception handling becomes part of your public API design, not just an afterthought. So let's quickly recap what we've covered today. We started with a real Spring Boot application using clean, layered architecture, and we saw how the service layer throws domain-specific exceptions for not found, duplication, and update issues. Initially, those exceptions bubbled up, and the way they ended up doing it was being turned into a generic 500 internal response. So we discussed why that was a problem, and then we introduced two key pieces. An API error, which is a record to define the consistent error, and we added a product exception handler, annotated with a REST controller advice to map all of our HTTP statuses and error codes into objects. So throwing a custom exception is only half the job. The other half is designing how that exception shows up over HTTP. And that's where REST controller advice shines. So if you've made it this far, thank you very much for watching. I hope you've learned something. Hit that like button if you did. And if you'd like to learn more, hit that subscribe button and turn on notifications so that you get notified when I post a new video or when I go live. And if you know a friend that might find this useful, remember to hit that share button. As always, keep your curiosity open, your skills sharp, and that coffee cup full. I'll catch you in the next one.